Okay, this is 11.1, Part B, areas of trapezoid, rhombuses, and kites. So, area of trapezoid. First off, keep in mind that trapezoid has two bases. They're the parallel sides. And once again, the height is going to be that perpendicular segment between the two bases. So the area is 1/2 times the height times the sum of the two bases. So find the area of each of our trapezoids. So area is going to be 1/2 times the height times the sum of the two bases. So you end up with 13 times 11, which is 143. Area 1/2 times the height, the perpendicular distance between the two bases, times the sum of the two bases. And then we get to these fun problems where you have to find the height and you have that 60-degree angle in there. I have a tendency of always using special right triangles. If you saw in the prior section, or as you can see as we're moving forward, you can do, instead of the equivalency square root, you could do decimal equivalency, which I would allow, and then you could use SOHCAHTOA, and you'll see that in the review. So this is the hypotenuse, which is 2 times the short side. So 12 equals 2s. So the short side equals 6. So that would be this little piece here. And the long side equals the short side times the square root of 3. So that would be 6 root 3. So that's my height. So I take area is the height times the sum of the two bases. So you end up with 45 times 6. Oh, I forgot the 1/2, sorry. So you end up with 3 times 45, which is 135 root 3. And then find the area of the isosceles trapezoid. So this is what you can do. It's isosceles. I can pull these two pieces down here. And then this piece, let me highlight it. This little piece right here that I highlight would actually be $10. Each of these pieces would be the same. So 10 plus 2x equals 30. So each of those pieces would be 10. Then you can use the Pythagorean theorem to find the height. And you get 24. So that area equals 1/2 the height times the sum of the two bases. So the original base was 30. So 40 divided by 2 is 20 times 24, 480. Okay, a rhombus. A rhombus, we are using the diagonals. They can be marked as inside or outside. Could also have So you could, again, have it written inside, outside. You could have it as the bisected diagonals. Okay? And in number 5, that's what we have. We have the bisected diagonals marked. So you have the full diagonals then are 20 and 24. Multiply 10 times 24, 240. Remember that diagonals of a rhombus are perpendicular. So I can find this piece by Pythagorean theorem. So you have 8, 8, 15, 15. So this is 1/2 16 times 30. 8 times 30 is 240. They just happen to be the same. And then our nice favorite one here, trying to find the height. So if it's 135 in that corner, it is 45 in that corner. And you know that this is 10 root 2. And each of these two little pieces are the same. It's the hypotenuse. Hypotenuse equals the leg times the square root of 2. So that means this is 10. So we have area is base times the height. Because this is a rhombus, it's a parallelogram. So you can do 10 root 2 times 10. 100 root 2. It's going to be area equals 1/2 diagonal 1 times diagonal 2. Remember, area is units squared, so when you do have units, you want to write them down. Area of a rhombus with a perimeter of 52 and a diagonal of 10. So one of the diagonals is 10. Okay, so that means I can draw, make them red. So I know